In this video, I'm gonna make AI learn to play Flappy Bird, except I'm doing it with C++ and no AI libraries. The only problem is I have no idea how to code this. So I found a guy on YouTube who made a great tutorial, and after a couple of days, I recreated Flappy Bird AI in Python. Then I just translated everything to C++. Along the way, I realized that everything is so much easier in Python than C++. At this point, I had working Flappy Bird AI. I know it looks bad, but I'll explain that design choice in a bit. First, let me show you how this works. For this project, we use the genetic algorithm. How this works is that you have multiple players and then see how long each of them live, which is their fitness. Players with high fitness are cloned and mutated slightly, and the process repeats until eventually the players evolve to become very fit. This imitates how genetics are passed on, and that's why it's called the genetic algorithm. Each of these players are just neural networks that get inputted data and return an output that determines if they flap at that frame or not. The three inputs are the distance to the top pipe, the horizontal distance to the pipes, and the distance to the bottom pipe. There is also a fourth node called the bias node, which is always 1. This just gives the AI more mobility to change. The AI's brain is just weights that each input node gets multiplied by, which added together gets an output. If the output is greater than 0.5, then the AI tries to flap. In this example, we only have 2 layers, the input and the output, but in more complex AIs, there are multiple hidden layers in between the input and output called hidden layers. Of course, there are a ton of other functions to make the evolution process work well. For example, we need an activation function, which introduces non-linearity and allows the AI to fit in more complex patterns. This part of the code is just a sigmoid function that serves as our activation function. Its math equivalent is just 1 over 1 plus e to the power of negative x. To show you what the activation function actually does, I created a simple neural network shown here. It has an input node, an output node, and 2 nodes in between. The output can then be calculated by the weights times the input node. More specifically, it's the input times weight 1 times weight 3 plus the input times weight 2 times weight 4. And you could factor this out into the input times the weights combined. And as you can see here, the weights combined is basically just another weight. So with this setup, you could basically just make another neural network with 2 nodes, an input and an output, and 1 in between. So in order to introduce some nonlinearity and allow this to become more complex, we need an activation function. And what this does is, for each node, instead of just multiplying it, you also pass it through the activation function. And after you do that, you would get this. The output equals weight 3 times the activation function of the input times weight 1. Plus weight 4 times the activation function of the input times weight 2. And as you can see, this is not linear, since you cannot factor out anything inside the activation function. Another useful function here is the kill stale species function, which removes any species that is not improved for 8 generations. This is helpful so that you don't waste all your players on a bad species that doesn't get anywhere. Using C++, I used SFML, which is kind of like Pygame. You can use it to draw shapes, text, and a bunch of other things. Downloading it is a bit more work than Pygame, but I'll link a good tutorial in the description. Now, let's look at some of the actual data. Underneath the actual Flappy Bird game, you'll see a bunch of data points. The first one is the number of pipes passed. That's basically just the best player's score. Next is the amount of generations. Every time all the players die, a new generation starts. So the amount of generations is basically just how much the players have gotten to evolve. Next is the amount of species. Players are sorted based off of how similar their brains are. If a player mutates a lot, they might form a new species. And under that is the average score. The average score increases in seconds as opposed to the number of pipes passed. This is better because it's more gradual, and two players that survive a different amount of time will be treated differently, even if they both pass the same number of pipes. The graph has a bunch of interesting patterns. The most notable is that the graph will be increasing over time. This is because as the players evolve, they're getting better at the game and they're surviving longer. Now let's watch some of the actual gameplay. I'll speed it up in some areas so that it doesn't get too boring. As you can see, in the beginning they're pretty bad, they're just learning how to fly. By generation 10, they can fly pretty well, but they can't get past the pipes. Then, by generation 35, they're flying pretty good. Now they just have to get a bit better and survive forever. Thanks for watching. Since you made it all the way to the end, consider checking out some of my other videos.